Hello everyone, this is Bhumika Mohan. In this video, I'm going to talk about the research related to computer networks, that is IPv6 network research. Coming to the contents of this video, first I'm going to talk about abstract, then introduction, literature review, methodology, outcomes, and then in the last, its conclusion. Coming to the abstract, the paper presents a performance evaluation of IPv6 networks for real-time applications using ISIS-v6 routing protocol simulated on the riverbed modeler. As real-time applications such as video streaming, VoIP, and online gaming demand very low latency as well as high reliability, the need for IPv6 to IPv6 transition necessitates careful assessment to ensure that some performance standards are met. The study analyzes key performance metrics including delay, throughput, and packet loss under varying network conditions. Simulation is adopted to test ISIS-v6 for its efficacy in handling IPv6 traffic relative to other protocols. Results show that the ISIS-v6 protocol is well suited for IPv6 networks because latency is considerably low and throughput on the network will be high enough to support real-time applications. This evaluation therefore shows the protocol's capability to optimize IPv6 networks for future real-time net communications needs, therefore making it a valuable point of input for network designers and operators as they are migrating to IPv6 infrastructures. Coming to introduction, the paper begins by addressing the growing importance of the Internet Protocol version 6, that is IPv6, as a successor to IPv4, primarily due to the depletion of IPv4 address space. This is mainly because the address space provided by IPv4 has been exhausted. The possibilities of making a leap to IPv6 are very much in order to accommodate the exponentially growing number of devices connected to the internet and even more in demand, particularly from the Internet of Things, that is IoT, mobile devices, and smart technologies. Because applications like VoIP and video conferencing, online gaming, and other interactive services depend on the quality of the network, they must have low latency with minimal jitter, high throughput, and low packet loss. Since such applications are very sensitive towards network delays, it is important to evaluate protocols within an IPv6 environment to meet performance standards. ISIS v6 is one of the very large, sometimes earth shaking routing protocols that have been very highly recognized for their efficiency in IP routing. The usage of ISIS v6 may be quite much compared to IPv4 in cases of IPv6 due to its hierarchical structure and the protocol scales better in larger network environments. However, performance of ISIS v6 in real-time applications over IPv6 networks has not been examined properly so far. The purpose of the introduction is to identify why ISIS v6 needs to evaluate the performance of an IPv6 network in the presence of real-time applications which motivated this study. By using Riverbed Modeler as a simulation tool, it will give insight into how the ISIS v6 routing protocol performs when handling real-time traffic over an IPv6 network. Given the background discussed above, this paper aims to fill in a gap in the literature regarding the efficiency of ISIS v6 for real-time communication in IPv6 and will contribute to gaining an understanding of how applicable IPv6 is to the future internet. This paper assesses a major network performance indicator, namely delay, packet loss, and throughput, by using performance simulations to determine if ISIS v6 will be an optimum choice to ensure a high quality service in IPv6 networks, especially for applications requiring real time responsiveness. Coming to the literature review of this paper, the literatures reviewed in the paper stress that routing protocols have emerged as key factors in achieving design network performance, especially for applications requiring real time services with the increasing transition to IPv6 from IPv4. The review analyzed the increased demand for IPv6 due to limitations of available IPv4 address space, among other limitations. Other interesting features of IPv6 with much improved address space, improved security, and better QoS capabilities are also discussed. The studies reference investigate the performance of different routing protocols on IPv6 networks, that is OSPF-v3, RIP-NG, and ISIS-v6, with specific emphasis on their efficiency when applied in real-time applications. The studies demonstrate that how a routing protocol is chosen directly influences latency, throughput, and packet loss, all of which are prime characteristics of services like VoIP, video conferencing, and online gaming. The review, therefore, focuses on more in depth analysis of ISIS v6, especially in very large scale networks and reliable routing of IPv6 traffic. However, its performance in real time applications has not been studied much. Based on that gap, the study is built to present an in depth analysis and full evaluation of how suitable ISIS v6 is for real time applications in an IPv6 domain. This is because realizing how IPv6, along with its related routing protocols, can support the resource requirements of real time applications in the network makes ISIS-v6 performance evaluation fit well as a topic of concern to be identified with the literature review. Coming to the research methodology of this paper, the research methodology of the paper is centered on a simulation-based approach using the riverbed modeler software. The methodology is structured to evaluate the performance of the ISIS v6 routing protocol within an IPv6 network, specifically for real-time applications such as voice over IP, that is VoIP, video conferencing, and other latency sensitive services. The key steps in this methodology is the first one is simulation environment setup. The study uses the riverbed modeler to create a realistic IPv6 network environment. The network topology consists of routers, links, and nodes configured to support IPv6 with ISIS-v6 as the chosen routing protocol. The simulation also includes traffic generators to emulate real time application traffic, focusing on key performance metrics like delay, throughput, and packet loss. The second step is protocol configuration. The ISIS v6 is configured as the primary routing protocol in the simulated IPv6 network. Its routing parameters are optimized to handle real time data streams, ensuring that the protocol can be properly assessed for its suitability in managing real time communication. The third step is performance metrics. Here, the study focuses on evaluating critical performance metrics such as first one is end-to-end delay, where it is used to measure the responsiveness of the network for real-time applications. Another performance metric is throughput, where it is used to assess the data transmission capacity of the network. The last one is packet loss, where it is used to determine the reliability of data delivery for sensitive applications. The fourth step is traffic simulation. Here, various traffic loads, including real time application data, for example, VoIP and video conferencing, are introduced into the network. These simulations are run under different network conditions to evaluate how ISIS v6 performs in handling the dynamic nature of real time traffic. The fifth step under the key steps is the comparative analysis, where the performance of ISIS v6 is analyzed and compared under varying network conditions and traffic loads. The results are compared with other studies or protocols where applicable to assess ISIS v6 efficiency in real-time application scenarios. Overall, the methodology relies on simulations to provide a detailed performance evaluation of the ISIS v6 routing protocol, specifically within an IPv6 network environment for real time applications. The study aims to identify how well ISIS v6 handles the demands of real time traffic based on the selected performance metrics. Coming to the outcomes of this research paper, the research reveals important insights into the performance of the ISIS v6 routing protocol in an IPv6 network, particularly for real time applications like VoIP and video conference. The key outcomes are summarized as below. The first one is end-to-end delay, where in case of normal loads of traffic, ISIS-V6 shows efficiency in the handling of real-time applications based on the requirements of managing end-to-end delays. However, when the load of traffic is increased, it also enhances the delay and defeats the purpose behind setting real-time communications by lowering the quality of the communication. It therefore means that ISIS V6 has good performance but runs into trouble when network gets highly congested. The second one is throughput, where ISIS V6 performed well as far as throughput is concerned because its rate of transmitting data ensured that real time applications always had sufficient data transit rates. When using the protocol, network bandwidth was used very efficiently, thus allowing it to maintain high throughput even at times when the traffic levels were changing. So, here is the calculation for average maximum throughput. Average number of packets received by average number of packets sent gives the average maximum throughput. And here is the average maximum throughput chart where it shows the graph representation of maximum throughput. And the video conferencing average throughput value is 84.3%, while the voice average throughput is 56.5%. Packet loss. The packet loss was relatively minimal during low to moderate traffic loads that could go to prove the workability of ISIS v6 in real-time data transference. When traffic volumes were high, packet loss increased, indicating possible issues that would deny quality in heavily loaded networks. Another one is scalability and network performance. Here, ISIS v6 demonstrates a good tendency to scale within the IPv6 network, extending to different network sizes and configurations. This thereby means that the protocol is best suited for large networks without affecting the delay, throughput, and packet loss. Feasibility of real time application. Overall, results indicate that ISIS v6 is a robust routing protocol of the networks in IPv6, particularly when supporting real-time applications. Nevertheless, at heavy traffic contention, delays might get worse and packet loss appears, which means there is opportunity for optimization or congestion management further. These results provide a comprehensive evaluation of ISIS v6 capabilities and its strengths and limitations when applied to real-time traffic in IPv6 networks. The conclusion of this video is the conclusion of the paper highlights the overall effectiveness of the ISIS v6 routing protocol in IPv6 networks, particularly for supporting real-time applications such as VoIP and video conferencing. According to the results yielded in the study, the ISIS v6 under normal traffic conditions presents fine performance concerning end-to-end delay, throughput, and packet loss, which categorizes it as a suitable routing protocol for the transmission of real-time traffic. However, the research has shown that the performance of ISIS v6 may degrade with the growing traffic within the network and increase the number of delays and packet loss. Such conditions may degrade the quality of service associated with real-time services. The protocol has been found scalable and reliable in nature, yet there may be a requirement to apply some forms of optimization or congestion management techniques to have the best performance even with high loads of traffic. In summary, though ISIS v6 is a robust protocol for applications of IPv6 in real time, careful management in a network environment is required for consistent performance in environments of high traffic, and further research and optimization may be needed to deal with these challenges. Thank you.